I'm going to create a foldable that's going to help us organize the concepts of linear equations. So this is something that I printed out that we're going to cut. It's blank on one side, but it has information on the other. So the first thing we're going to do is we're going to cut along this line here so that we can make a square. And then what we're going to do, if you see, there's like a square in the square. So we're going to fold in each of these corners to the center. Almost like making a paper airplane. Fold in the corners. You want to crease it really nice on the creases. So now we have a square. Then each of these little corners we're going to fold back just a tiny bit. Like so. So we want to have this in the right position. So we're going to look inside. That's upside down. So this must be the top, which is blank. Hold on. Okay, so the top is blank. Then I can read this straight up. And then and everything now is in the right direction for me to be able to read. So what I'm going to do, first thing I'm going to do is I'm going to start here. And I'm going to write into center 3 forms of a linear equation or linear function. So right here in this box in the center, I'm going to write 3 forms of a linear function. So that goes right in the center. The top flap should be empty. Okay, there should be nothing in there. We will write in there. So the 3 forms, there's one form to the left, one form to the bottom, and one form to the top. This one over here on the right, pull this back just a little bit more so I can see that arrow. I'm going to write slope. So over here, this is slope. Okay, so slope is something that we need to know for the equation of our lines. So before we get any further, let's go ahead and let's look at this paper here. So this paper here is actually 3 sections. So we're going to cut off this excess on the side. We can discard that. So I'm going to cut them up into the 3 parts. So if you look at each of these 3 parts, you'll notice that they have different number of spaces, and that's for a particular reason. So this one here we're going to use last, so I'm just going to put that to the side. It's probably the most complicated of them all. And then I have to say, let me see, 1, 2, 3, 4, 5, 6, 7. So this one has 7, and this one has 1, 2, 3, 4, 5, 6. So let's take the one that has 7, and we're going to fold it on that crease, on that line, like so. And then inside, or on top, I should say, of each of these flaps, I'm going to write the equation of a line in standard form. So this might be a little bit different. I could start with slope-intercept form, but I'm just going to start with standard form. So we're going to write A, it's capital A, X plus B, Y equals C. So if you've noticed, I've put each of those, let me see, let me get it a little closer, on one of those lines. Okay, so now what I'm going to do is I'm going to, actually this one here, I don't cut this one at all. I'm going to leave this one whole, just like that. Okay? Because there's really nothing going on with standard form. It's just kind of boring. So let's put that to the side now that we have that done. And then we're going to take this other paper and we're going to fold it along that line. Put a crease through there. So now we have all of our tabs showing. And we're going to write slope-intercept form. So that would be y equals, and then I'm going to write m for slope, x plus b. Okay? Now, I'm going to cut certain sections. I'm going to cut the M section right through here. So on either side of the M, I'm going to go snip, snip, okay, right on either side of the M. And then I'm also going to cut the B. Okay? So the only thing that I have kind of free is my M and my B. So then what I'm going to do is I'm going to take my glue and I'm going to put just a little bit of glue on the Y equals, and I'm going to glue that down, and a little bit of glue on the X plus equals. Okay, so those, we don't need to look under those. The only thing we're concerned about is the M and the B. So underneath the M, we're going to write, we'll turn it sideways, and we're going to write slope and that's also rate of change. So underneath slope, I'm going to write rate of change. Okay? So we also know rate of change is rise over run. So we're going to write rise over run. There are many more things we could say about slope. But for right now, on that little slip, that's what we're going to write. So for B, we're going to open up B, and we're going to write this like this. We're going to say not just the y-intercept, we're going to say the y-axis intercept. Okay, the y, we usually just truncate it to say the y-intercept, but I want you to think of that as the y-axis intercept. And the coordinate for the y-axis intercept, there's some value for y, and x is always 0. So you need to remember that. The x-axis intercept is where x is 0 and y is some number. Okay, so we just finished our slope-intercept piece. So before we go on, let's go back to here and let's glue some of these on. Okay, so we're first going to take our, let me back up the camera a little bit. We're first going to take our standard form, and on the back side we're going to put just a tiny bit of glue. You don't need much. And we're going to glue it on the flap that when we open it is empty inside. So we're going to glue it here. Leave some room because we're going to write right on top of it standard form. Okay? So this is called standard form. Okay? So it should look like that. And then we're going to take our slope intercept and we're going to put this one on the side. So I'm going to turn this sideways. I'm going to turn it over to the back. Put a tiny bit of glue. Don't need a whole lot there. I'm going to put that on there. And right underneath, I'm going to write slope intercept form. Okay? So the last form that we're going to look at, and some of you may know what it's called, is the one with all these little tabbies. So again, we're going to go ahead and we're going to fold that down like so. And we're going to cut each of the, oh, sorry, before we cut, let's write what's in here. So this is going to be point slope form. So point slope form is y minus y sub 1, that's in the basement, it's the last name, is equal to m parentheses x minus x1 parentheses. So every single symbol has its own space. So pay close attention to what we're going to cut on this one. We're going to set free, so to speak, the y sub 1. We're going to cut the line on each side of y sub 1. Then I'm going to look at my slope, and I'm going to cut the line to each side of my slope. And then I'm going to go to x1, and I'm going to cut the line to each side of the x1. Okay, so basically I want my x1 to be free, I want my slope to be free, and I want my y1 to be free. So those three do not get glued down, the others get glued down. So I'm going to glue down the y minus, tiny bit of glue, doesn't take much. I'm going to glue down my equal sign. I'm going to glue down my parentheses x minus. And I'm going to glue down that very last parentheses. Okay. So let's write down what's on what's on the inside. So when I'm looking underneath the y sub 1, I'm going to write down y coordinate. So this is y coordinate of a point. So this is the y coordinate. So when we're talking about the y coordinate, when we're given a point, we're given x sub 1, y sub 1. Okay, so what we're looking at, and let's take a highlighter, is I'm only interested in the y value of that point. Okay, now we've already talked about slope. So inside where it says slope, I'm going to write slope. And this time I'm going to write the equation because this is so skinny, I'm going to write it like this. The numerator is y2 minus y1, close parentheses, divided by, it's hard to write on this little piece of paper, parentheses, x2 minus x1. Okay? So there, that's my equation for slope. And then the last thing I have is my x sub 1. So underneath the flat for x sub 1, I'm going to write x coordinate. And again, I'm going to write x sub 1, comma, y sub 1, close my parentheses. And for my x coordinate, I am only interested in the x coordinate of the point. So now what I'm going to do is I'm going to take this and I'm going to glue it on to the bottom part of my square foldable. Bring it up to where it will fit like the corners without going over. And underneath, I'm going to write point, slope, form. Okay, so we have all the outside done of our foldable. So now we're going to look at the inside. So before we go anywhere, we need to know pretty much what slope is. So let's talk about slope. So if we open up our foldable, we can see that we have two sections. We have a graph on the top and a graph at the bottom. Okay? So what we want to talk about is slope, and slope is rise over run. So I'm going to get some different colors here so maybe we can see this a little bit better. So slope, which we represent with the letter M, slope is rise. Oh, I'll use red for rise. Sorry, rise over run. Okay, so what does that mean? So if I'm looking for rise, my rise is how many up. So if I'm going from this point to this point, I want to know how many up it is. Well, that would be 1, 2, 3, 4. Okay, so this is my rise, and that's actually a distance of 4. Okay, so then that means that my rise is 4. So now we need to figure out what our run is, and I'm going to put M equals here. I'm going to figure out what my run is. So my run is from here to here, and that's going to be 1, 2, 3, 4, 5, 6. So that looks like 6. So from here to here is 6. Okay, so when we're looking at this, we should be able to tell that we could actually reduce this if we wanted to. Okay, so if we were actually going to figure out the final slope, that would be reduced to 2/3. Okay, so another way of looking at slope is, I'll write this down. So slope is also considered the change the change in y divided by the change in x. Okay, and we can see that here, that y changed from -2 to 4, and x changed from, from -1 to 3, and x changed from -2 to 4. Okay, so that was our change. So let's talk one more thing, and then we'll be done with slope, at least for this one. So I want to know, what's the distance from, let's see here, the green was our run, so we'll talk about that. What's the distance from -2 to 4? From -2 to 4, this way. Okay, so that's going to be our change in x, which is going to be, so when we're looking at our change in x, it's going to be, we're going to start at 4, and we're going to do -2. So the change in x is 4 plus 2, which is change in x, which is 6. Okay? So if we want to know the change in y, which I should have done first, I'm going to kind of squeeze this in here. So what's the distance from, well, what's our y? -1 to 3. From -1 to 3. Well, our change in y is going to be 3 minus -1. So that means that our change in y is 3 plus 1, which means that our change in y is 4. Okay? So that's what we had. Our change in y is 4, and our change in x is 6. So that's how we could go from point to point to find the distance.